Alright, for today we're going to talk about segments, and if you remember, we talked about segments when we were doing points, lines, and planes. So if you forgot what a segment was, go back and look at your notes. And so segments are, if you remember, segments are part of a line that has two endpoints. And these are one-dimensional. If you remember, dimensions are a form of measurement. So because they're one-dimensional, that means that they only have one measurement. We measure segments with the measuring device. The one that you're probably most familiar with is a ruler, and we'll be using rulers in our classroom to measure stuff later on. But you can also use other kind of measurements like odometers, which I have in cars. They have some fancy stuff that you can use lasers to measure distance. And there's also a lot of many other devices. But the one that we usually use is going to be the ruler. We can also use many different units, such as inches, feet, meters, miles, and a bunch of other stuff. So just as you're doing your problems later on, just make sure that you pay attention to the measurements, because like if you're dealing with miles, then your answer is going to have to end in miles. And the same goes for inches, feet, and meters. Alright, so this is a notation. Okay? In notation, this is not a definition. Notation is going to be the way you write things. Like before when we wrote AB with the little line and the arrow on the side, that's notation, and that means like array. Okay, and so when we're talking about distance, we can say that when you just see two letters next to each other, without the arrows, without anything on top, just two letters or two capital letters, which are 2 points next to each other, that means the distance between points A and B. For example, if you look at the picture on the right there, we'll call the left point A, and we'll call the right point B. And if I get my ruler and I measure that, it seems to be about 2 inches in your thing. I didn't really measure it. I just kind of took a guess. But we can say something like this: AB equals 2 inches. So anytime you see these two letters next to each other, it just means the distance between those 2 points. Now, it is very easy to confuse this AB with segment AB, line AB, or also array AB. So just make sure you know the difference. When you don't see anything on top here, just remember that it means distance. Okay, so AB refers to the distance, and the other three refer to shapes. Okay, so congruent segments are segments that have the same length. Okay, and anytime you see the word congruent, it just kind of means the same distance or the same measurement. Okay, so congruent segments are going to be segments with the same length. And the symbol for congruence is going to be this little equal sign with a little squiggly line on top. So go ahead and copy that in your notebook. That's going to be congruent. Okay? So for example, on the right picture there, we have two segments. Let's say I call the first one AB, and I call the second one segment CD. If I were to measure those, they might be both like 2 inches. Okay, so we can say that the top one is going to be congruent to the bottom one, and on your pictures you're going to see these little lines like that. That's the symbol for congruence on a picture. Okay? But if you want to write it out that those two segments are congruent, you'll write something like this: segment AB is congruent to segment CD. So once again, that little equal sign with the squiggly is a congruent symbol. And then sometimes you notice here I have these once again I have these lines. You don't have to put those circles on your paper, but those lines mean congruence. Okay? And sometimes you might see one mark, you might see 2 marks, you might see 3 marks. I'm going to give you an example of when you can see when you might see 1 mark or 2 marks or 3 marks. For example, if you look at this segment here and look at that segment, let's say I measure them in the same distance. Okay, well I can put a 1 mark here and I can put a 1 mark here to signify those are congruent. Now if you look at these two here, this one there and this segment there, those are congruent, and so I don't want to put 1 mark. Okay, why? Because if I put 1 mark, then I'm kind of saying that this one is congruent to this one, and they are not. Okay, so what I'm going to do is I'm going to put 2 marks here, and I'm going to put 2 marks here to signify that these two are congruent, but those two are not congruent to either this one or that one. Okay? Now if you also look at this last one here and this last one here, those two are the same distance. Okay? So what I can do is I can say, hey, I'm going to put 3 marks here to signify this congruent to this one here, but these 3 marks are not congruent to that one or this one here that has the 2 marks. It is also very easy to confuse the equal sign with the congruent sign. Okay? Sometimes you might mess up. I'm not going to really take off points because a lot of people get this wrong at first, but usually you'll get the hang of this. The equal sign, which is that one, refers to numbers and measurements. Okay? And like you've been seeing this before in algebra 1, when you put like x equals to 4, that's talking about 4 as a number. Okay? But the congruent sign, which is that little squiggly on top of the equal sign, it refers to shapes with the same measurements. Okay? Try not to confuse them. Okay? Let me give you an example of what I mean. If I say plane ABC equals to plane DEF, okay? So remember, equals, this is going to be wrong. Okay? This is going to be wrong. Why is this wrong? Because equals refers to numbers and measurements. We do not measure this plane. Planes are not numbers. Okay? Planes are shapes. And so for this to be correct, you would have to put a little squiggly sign to make it correct. And let me give you another wrong example. Sometimes you might write like this, AB is congruent to 5. Okay? Now this is also wrong because congruence refers to shapes, okay? Shapes. And 5 is not a shape, and AB is not a shape. It's a distance, okay? But it's not the shape. If I were to put like a sign on top here, then that becomes a shape. But because it's not there, this is not a shape. This is just a distance, okay? So it refers to numbers, so this will be wrong. In order to make this right, you would have to take off this congruent symbol on the top, or the squiggly, to make it an equal sign. Okay? So just be careful with that. All right. So the segment addition postulate. Now, if you remember, we just went over postulates, and postulates are rules that are kind of common sense that everybody will probably figure this out. If I didn't give you the rule, you can probably figure this out. For example, let's call that A. And let's call that C, and we'll call a point in the middle B. When you have B in between 2 points like A and C there, we can kind of make a formula that relates these two segments, the two smaller segments, to the bigger segment. And it's just common sense. For example, say I started off at San Francisco, and I want to travel, let's say, to Colorado. So and I go over here to Colorado, and I measure that distance. Let's say I take an airplane, so I go straight, and it measures 500 miles. And let's say I want to go from Colorado. I stop there, and I want to go from there to, let's say, Boston in a straight line. Okay? Then I measure from Colorado to Boston, and I traveled 1,500 miles. Well, then kind of common sense tells you how much miles did I travel from San Francisco to Boston. So if you want to pause it and figure out how much miles I traveled. But I mean, I don't have to tell you the rule. I'm pretty sure that you can figure this out. How much did I travel? Well, I traveled, 500 miles from here to here. 500 miles plus 1,500 miles. That means I traveled 2,000 miles.
Bruh.
So up here, we can say, hey, if I have from A to B, plus the distance from B to C, then how much is the whole distance? Well, the whole distance would be from A to C. So here's the formula. You can write over here. So if points B is between A and C, then I know that AB plus BC is equal to AC. Okay? And you can also write it here on the bottom of the shape here, just so you can have a formula. But that's the formula. It's kind of just a common sense formula, and I'm pretty sure you could have figured that out without me having to tell you that formula. So let's go to example 1. For example 1a, it says find NQ. Now remember, what does this mean? When you don't see a line up here or anything up here, it means the distance from N to Q. And this is pretty much a common sense. I mean, you can probably figure this out. But how do I get the distance from N all the way to Q? Well, if I travel 4 units, and then I travel 17 more, okay, so NQ would be that 4 plus 17. And if I add those together, I get the NQ. 4 plus 17 is going to be 21. And then for example B, same thing. Find the distance from X to Y. Okay. Well, if you notice here, XY is only this little part here on the left. It's from X to Y. Yeah, but I can use the same formula because I know that from X to Y, plus 29, I'm going to write that down, from x to y plus 29, those two pieces should equal to this whole piece, which is 71. Okay, so I'm using the exact same formula, and then I can use my algebra. How can I get this xy by itself? Well, I can subtract. I can do the opposite, and I can subtract 29 from both sides. This will cancel. That will give me that xy is equal to 42. Okay, now for example 2, this is where we're going to see a little bit more on the algebra. It's not just numbers, and it's not going to be as easy as the last one. But it's going to be the exact same concept. Okay, if I ask you find the distance from B to W. Okay, so if I come over here, B to W is the smaller distance on the right. But I notice the same formula is going to be, hey, the distance from TV plus the distance from B to W will equal to the whole distance from B to W. And I can do the exact same setup. I can say, hey, 3x plus x plus 8. I'm going to write that down. 3x plus x plus 8 is equal to the whole thing, which is 32. And then I can use my algebra to find the value of x. Okay? Combine our like terms here. I have 3x plus x, that's going to be equal to 4x. Bring down the positive 8. Bring down the equals 32. How do I get rid of that plus 8? Well, I subtract 8. Cancels, and I get 4x equal to 32 minus 8 will be 24. And then I can divide both sides by 4. And I get that x equals to 24 divided by 4 is going to be 6. Okay? But that's not the answer. Okay? That's the value of x. Okay? But the question says find the distance from B to W, because we know VW, according to this diagram, VW is x plus 8. So VW is x plus 8, and I just found x. Then I can substitute. X is equal to 6. And I can plug in 6 here for x. And 6 plus 8 is going to be 14. Okay, so the final answer is VW equals to 14. So be careful with your assignments. Sometimes they might say, hey, find the value of x. And we found the value of x, and this would have been our answer. But because they didn't ask you to find x, they ask you to find VW, then you have to make sure that you find the distance, okay? All right, for B, find the distance of YZ. So YZ is kind of the same thing here on the right side, and so our setup is going to be the same. We know that this piece plus that piece is equal to the whole piece. Okay? So I can say 2x plus 3 plus 3x minus 1 equals to 27, okay? So 2x plus 3 plus 3x minus 1 is equal to 27. So I can combine our terms, and I can say here 3x plus 2x plus 3x is going to be 5x. And then 3 minus 1 is a positive 2. That equals to 27. And what do I do after that? Well, same thing as the last example, I can get rid of that plus 2 by subtracting 2 to cancel it out. This is going to cancel. Now I get 5x equals to 27 minus 2. It's going to give us 25. And if we divide both sides by 5, this cancels. And get x equals to 25 divided by 5 is 5. Okay. Now once again, this is not the answer. If they ask you find the value of x, then we would have been done. But because they're asking me what's the distance between points y and z, then I have to come back here and I have to say, well, if I just found x was 5, then I got to plug in 5 there. Okay, I'm going to put it on the right side. YZ, which is 3x minus 1, is the same thing as 3 times 5 because x is 5, so I can substitute 5 there. Minus 1. 3 times 5 is 15, and 15 minus 1 is going to be 14. Okay, so the distance from y to z is going to be 14. Okay, midpoint. So a midpoint is a point that divides or bisects a segment into two congruent segments. So for example, if I have A and I have a point B there, and I have segment AB, well, a point right in the middle, right there, that divides these two segments into two equal segments. So remember, those little lines mean they're equal. That point M in the middle, it will be the midpoint. So it has to slice the segment into two equal pieces. And we can say M is the midpoint if segment AM is congruent to segment MB. In geometry, the word bisects means to cut exactly in half. And you're going to see this word bisect in later sections. But anytime you see the word bisect or a bisector, it's going to mean to cut something exactly in half into two congruent pieces. For example, a segment bisector. So a segment bisector is going to be any figure that intersects a segment at its midpoint. The figure could be a point, a line, a segment, a ray, or a plane. Okay. Take for example, once again, we have a segment here. And well, if I have a point that cuts this into two equal pieces, then that point is bisecting that segment, and therefore that point is a segment bisector. Or I can draw a segment kind of going through that midpoint, okay, because that segment is cutting that, like I say, the red segment is cutting the black segment into two equal pieces, then that segment is also a bisector. Or it can be a line or a ray, it can be any kind of shape. For example, that red line is also bisecting that segment into two equal pieces. So a bisector just means anything that's going to cut something exactly into two equal pieces. Now let's look at this example, a pretty easy example. For example, to find the distance from A to C if the distance from A to B is equal to 10 centimeters. Okay? So they're saying that from here to here, this is 10 centimeters. Okay? Well, you can see here the line L is bisecting the segment AC because these two pieces are equal. Okay? So this line will be considered a segment bisector. And if that's 10 centimeters, then this is also going to be 10 centimeters. And kind of common sense tells us that, hey, how do I get the distance from A to C? Well, from A to C over here, it's just basically 10 plus 10. So the distance from A to C is 20 centimeters. Same thing for example B. Okay? It says find xy, or the distance from x to y, if the distance from y to w is equal to 30 feet. So it's saying, hey, from y to w, way from here to here, this is 30 feet. And so how much would xy be, or the distance from here to here? Well, we know that these two pieces are equal because it gives you the little congruent marks. And so it's being cut in half. So how can I do that? I can get half of 30. But half of 30 will be 15. So this side has to be 15 feet as well. This side over here has to be 15 feet also. Okay? And therefore, the distance from y to x, or from x to y, is going to be 15 feet. It's just half of 30. And then I'm going to do another example very similar, but now we're going to start using some algebra. Same thing here. Find the distance from L to N. Okay, so the distance from L to N is this whole thing here. Okay? And you might be tempted to write down x. Don't write this down because this is actually wrong. But you might be tempted to write down x plus 9 plus 4x equals to what? The whole thing. But I don't know the whole thing. And so I cannot use the segment addition postulate. Okay? But what I do know is that these are equal. And these are equal. And so x plus 9 will equal to 4x. And that's going to be your setup when you see two things are equal. X plus 9 is equal to 4x. And then you can solve for x by doing the algebra. How can I bring this x to the right side to combine it with this x? Well, there's an equal, so you don't add them. But I can do the opposite of adding x to 9, and I can subtract x from both sides. This will cancel, leaving you with 9 equals to, and then 4x minus x will be 3x. And then I can divide both sides by 3. This cancels, and I get x equals to 3. Okay. Now, once again, they're not asking us for x. They're asking you for the distance from L to N. And so if I come back over here, I know x is 3. Okay? I can plug in 3 here, and I can plug in 3 here to get the distance from L to M and the distance from M to N. But if I plug in 3 here, 3 plus 9, that will give me 12. If I plug in 3 on this side over here, 4 times 3 is also 12. And you can see that they're equal because it has to be. Okay? And then 12 plus 12 will give you the whole distance. And 12 plus 12 will tell you that Ln is 14 units long.
Bruh.
For example B, it says find the distance from A to M. How can I set this one up? Same thing. I know that this piece equals to that piece. And then all I have to do is write down x plus 20. It's going to equal, okay, it's going to equal because they are equal to each other, 5x minus 4. And I can subtract this x here to get rid of it, okay? And I can bring it to the right side with this 5x. And so I'm left with 20 on the left side, and then 5x minus x is 4x. And I can subtract 4 here on the right side, or just kind of bring it down. And then how can I bring that minus 4 to the left side? Because I can't combine it, but there's an equal sign here. So I can do the opposite and add 4 to both sides. This will cancel. 20 plus 4 is 24. And then I bring the 4x down. And I can divide by 4. I can divide by 4. Get x by itself. 24 divided by 4 is 6. Okay, and then once again, how can I find the distance from A to M? So here's AM. And all I have to do is plug in 6 right there. Okay? So AM, you know, is x plus 20. But because we said x was 6, I can plug in 6 there. 6 plus 20 is going to give us an answer of 26. So that's the final answer. The distance from A to M is 26. What is wrong with the statement? I went over earlier because it says AB is congruent to 5 kilometers. So what's wrong with this? Remember, congruence is talking about shapes. 5 kilometers is not a shape. And the distance between 2 points is not a shape. Okay? So that is wrong. This should not be a congruent symbol. It should be an equal symbol. And for letter B, it's kind of the same thing. What is wrong with the statement? Okay, equal should be numbers. Okay? Segment MN is not a number, and segment XY is not a number. These are shapes, and when we're dealing with shapes, if they both have the same distance, we would say these are congruent. Okay? Because equals, once again, is for numbers, and congruence is for shapes.